Okay, the next section we have is section 5, special factoring. So this is going to include greatest common factor, sum and difference of cubes, etc. All right, so number 1, we need to factor completely. So I have x cubed plus 8. All right, so this is called the sum of cubes. Now, a cubed plus b cubed, I always say there's a pattern. So it's going to factor into a binomial and a trinomial, so 2 terms and 3 terms. The first one's you're just going to drop the cubes, a plus b. The second set, you're going to square the first thing, so a, so it's going to be a squared. And then the middle, you're going to multiply the 2 together, so ab. And then the last is you're going to square the last term, so b squared. Okay, and then I always say my signs are same, different, and then always plus at the end. So I'll say that over and over, same, different, plus. So in this case, we had the same sign as what we had before. It was a plus before. Then I'm going to have a different, so a minus sign, and then I'm going to have a plus sign at the end. All right, so this works for a cubed minus b cubed as well. So if I have a cubed minus b cubed, I'm going to go full screen here. That's going to be a minus b times a squared, so square the first, multiply the 2 together, ignore the signs, just ab, and then square the last, b squared. And then it's same, so they're the same sign, minus, different, so plus, and then last is plus. So that's how you would do a difference of 2 cubes. Okay, so when I see number 1, what's being cubed? I have x is being cubed, and I have 2 is being cubed. So you can memorize the a cubed plus b cubed formula right here, and just plug in a is x, b is 2. Or you could just remember the pattern. So just drop the cubes, x plus 2. Square the first, x squared, multiply the 2 together, 2x, square the last, 4. Same, different, plus. Okay, that's it. That's as far as it factors. All right, so same thing for number 2 and number 3. Notice you need to think about what's being cubed on number 3 each time. So you'd have 3x is being cubed, and then 5y is being cubed, and then finish it out. All right, number 4, I have x to the 4th. That's just like normal x squared. You're just going to have x squareds to begin with instead of x's. You need to think of numbers that multiply to be negative 80 for our last spots, because it's just reverse FOIL. Those last numbers multiply to be the number that's left. So numbers that multiply to be negative 80, I could have negative 8 and 10. Let's write them out. So 8 and 10, 4 and 20, 5 and 16, 1 and 80, lots of different factors. All right, now think of ways that you could combine to get 11. So the only ones that are going to combine to get 11 is 5 and 16, right? So let's put 5 here and 16 here. I need them to multiply to be negative 80, so one needs to be positive, one needs to be negative. And when you check the outer and inner, they need to combine to be positive 11x. So that means I need positive 16, and I need negative 5. Okay. Now, if those had been the other way, if it had been negative 16, then you would have the difference 2 squares, and you could say it's x plus 4 times x minus 4. But since it's a plus in between, they are perfect squares, but it's not the difference of 2 squares. It's not a minus. So that's as far as it goes. Now this one does have a minus, but 5 isn't a perfect square. So we can't break it down anymore. That's as far as this one factors. All right, number 5 is just a split the middle one. So the first terms have a c in common, and the second terms have a b in common. So work from there. Number 6, mine has AP written in the middle of it. Okay. Number 6, pull out a common factor. So when you do that, they have a common factor of 2. So I'd have x squared plus 25y squared minus 10xy. And when you look at that, you may not recognize it immediately that you can factor further, but you can. We just need to rearrange our terms. So now I can see at the front of my 2 sets of parentheses I need x's, and at the back I need something with y, right? So that way I get my y squared. And this is actually what we call a perfect square trinomial, because when I factor, it's going to be x minus 5y times x minus 5y. That way my outer and inner combine to be negative 10. So you can kind of recognize this sometimes. If you take the square root of your last number, so 5, and then multiply by 2, that's the pattern. So that's called a perfect square trinomial. So we would write our final answer as 2 times x minus 5y, all of that squared. Okay, number 7, that's really tricky. So number 7, you can try to split the middle, but when you try, it's not going to work. Like, you'd have 1 and 12 as your coefficients over here, and then if you pull out a common factor, you'd have 4 and 1 as coefficients over here. It's not going to work. Okay, so this is actually a trick. I did notice there's some squares in it. I have x squared and I have y squared. So, and then I realized, well, I just did what I call a perfect square trinomial, so maybe it has something to do with that. So see the x squared plus 12x plus 36, that's the perfect square trinomial. So just that part right there is x plus 6 times itself. So it's x plus 6 squared minus 9y squared. So now it's the difference of two squares. So you guys know the difference of two squares. Like if I had 2x squared minus 36y squared, it's just going to be 5x plus 6y times 5x minus 6y. That's why it doesn't have a middle term here. That's why it's only two terms, because the outer and inner terms cancel. Well, same thing with this. This is two squares. Something's being squared minus something being squared, right? So what's being squared? So the first one is x plus 6 is being squared. And the second one is 3y is being squared. So that means I can factor into x plus 6 minus 3y times x plus 6 plus 3y. Right, there's the first term. Here's the second term. Okay, difference of two squares. That's as far as it goes. All right, and then number 8 and 9 aren't too bad. Number 8, you probably want to split the middle. Number 9, pull out GCFs. Okay. Transformations. So if f of x equals x squared minus 1, describe in words what the following would do to the graph of f. All right, so the big thing to remember is if numbers are inside with the x, it's affecting the x value. And when it's inside, it does the opposite of what you would think. And since it's affecting the x value, it's going to move like right and left. It's going to do like a horizontal stretch for compression, things like that. All right, if it's on the outside, so we're not replacing the x, we're just doing something to the whole f of x term, then that's affecting the y value. And that does exactly what you would think it would do. So on this first one, if I have f of x minus 4, all that's going to do is shift it down 4. Number 2, I would think that it would move to the left since it's negative, like negative numbers move to the left, right? But it does the opposite of what you think, so it's going to go right 4. Whenever you have a negative, it's doing some kind of reflection. So since I have a negative out front, it's not in parentheses with the x, so it's not affecting the x value, it's affecting the y value. So my original was x squared minus 1, so going through 0, negative 1. And since it's affecting all the y values, any y value I had is now going to go to the opposite location. So I don't know the best way to draw this. So this point is now going to flip over the axis over here. My point 0, negative 1 is now going to flip to 0, positive 1. So basically it flips the whole thing upside down. So there's a reflection over the x-axis. And then it's also going to go, since it's inside with the x plus 2, it does the opposite of what you think. So you would think to the right 2, but it's actually to the left 2. Okay, number 4 involves what we call a stretch or compression. Since it's outside, it does exactly what you think. So I would think if you're multiplying your y values by 5, they're getting bigger. So you're stretching vertically. So number 4 is a vertical stretch by 5, and then it's going up 3. And then this one's the opposite of what you think. So I would think if you're multiplying by 2s, you're doing a horizontal stretch, but you're actually going to do the opposite. You're doing a horizontal compression, so we say by 1/2. So instead of multiplying by 2, it's like you're dividing by 2. So it's a horizontal compression by 1/2. So basically your graph from before, so going through 0, -1, is going to squeeze in, so every single x value is going to divide by 2. So it's going to be like there, there. So it's going to look something like that. So it's going to shrink in. Okay, and then when you have the absolute value of any function, all that does is makes all the y values positive. So what you had before was going through 0, -1. Almost all of it's positive. So this part stays exactly the same. But all those negative y values now flip up. So your final graph looks something like that. All right, so you could say something like all values are now, or all y values are now positive. Okay. Okay, this part involves sketching, so it's going to be a little tricky, but just think about individual points. So if I had 2 times f of x, that means all my y values are going to be multiplied by 2. So I would look at some important points to help me. So those are all important points. So I'd have -4, and my y value is 0, so it's still 0. My x value is 0, my y value is 2. If I multiply my y value by 2, I'm now going to be at 4, so it's going to be up there. Before I was at 2, -2, so go over to 2 along the y-axis, and instead of being at -2, I'm going to be double that, so -4, so it's going to be down there. And then I had 3, 0, so now multiply the y value by 2, so it's still 3, 0. Okay, so it just stretched it out vertically. So it was a vertical stretch by 2. All right, and you're just going to kind of go through and do that for each one. All right, we'll stop there.